All right, now here's the first worked example. It's saying find the integral of cos to the power of 5x with respect to x. You say, which case does this fall into? Well, this falls into case 1, where you have either cos or sine being odd, but not both. So here we have cos being odd. And we said when we have them being odd, what do we use? We use the famous trig identity that says cos squared x plus sine squared x is equal to 1. Oh, beautiful. So what am I going to do now? Well, what you're simply going to do is this. You go to the cos to the power of 5x and you split it to the highest even power of that cos, and then you remain with one more odd power. So this is cos to the power of 5, right? The highest even power that is before 5 is 4. So what I'm going to do is I'm going to say, well, I have cos x multiplying cos to the power of 4x. So I've split it into the highest even power, and then I remained with one more cos x, which is like 1. So this is just how I separate it. Because what I know is that cos x times cos to the power of 4x, because the base is the same, I add the powers if I'm multiplying. So this cos x is raised to the power of 1 and this is raised to the power of 4. It will simply go back to this one. So you've seen the very first thing you're going to do is split it up like that. And then once you split it up, you know that cos to the power of 4x is equal to cos to the power of 2x raised to the power of 2 again. Because if you raise a power to another power, then you are going to multiply the powers. So that means this would be cos to the power of 2 by 2. Because cos squared x is the same as cos x squared, right? Is the same as cos x squared. And we have raised it to the power of 2 again. So the powers multiply, right? Okay, so this is going to be cos to the power of 4x. So that's what I use now. I am going to say, well, that means that what is cos squared x anyway? Well, cos squared x will be equal to 1 minus sine squared x according to our identity, right? According to our identity. So I'm going here and I'm going to say this is the integral of cos x multiplying cos squared x raised to the power of 2, and this is dx. And that means it's the integral of cos x multiplying cos squared x is 1 minus sine squared. So it's 1 minus sine squared x squared again. And this is with respect to x. Therefore, so what are we going to do? Well, you expand this one. So it'll be the integral of cos x multiplying. Well, if I am expanding, let me just show you. If I expand a plus, or let's say a minus b, all squared, right? The first thing I do is I square the first term. That would be a squared. And then I multiply these two terms. So it's going to be a times negative b, and I get negative ab, right? But then when I get that answer, I'm going to then multiply the answer by 2. So I get negative 2ab, because I'm going to have 2 of them. And then, so this would be minus 2ab. Then I square the last term, which is negative b all squared, and I get b squared. So that would be plus b squared. That's the same thing I do here. Okay, I'm just teaching you a shortcut. So you square 1, it becomes 1. Nothing changes. Then you say 1 times negative sine x. That's negative sine x. And then times 2, that's negative 2 sine x. Sine squared x, rather. Negative 2 sine squared x. And then if I square negative sine squared x is the same as positive sine squared x being squared. So it's sine squared x being raised to the power 2. Again, the powers multiply, and I get plus sine to the power of 4 of x. Okay? And all this is with respect to x. I hope you see it. Now, what am I going to do? Well, here is an interesting thing. The first thing you can do, rather, is just to see that you can multiply by cos into this whole bracket and expand. So it's going to be cos times 1 is just cos x, then minus cos x multiplies sine squared x. So it will be minus 2 cos x minus 2 cos x sine squared x, then plus cos x times sine to the power of 4x is cos x sine 4x, okay? And all this is with respect to x. Well, how nice. If I have things separated by a negative sign or an addition sign in integration, it's very easy because I'll be integrating them one by one. Nothing changes. Oh, yeah. So here, what is it going to be? It's therefore equal to the integral of cos is sine, okay, because sine is what gave me cos. So it'll be sine x, okay, it's a positive sign, because if I differentiate positive sine x, I get positive cos x. And then I say, well, I've come to this second one, right? So I can now say minus the integral of, if you like to separate it, maybe let me just do it for the benefit of somebody who would need this. You can separate it like we always do to say integral of cos x with respect to x minus the integral of 2 cos x sine squared x with respect to x plus the integral of cos x sine to the power of 4x with respect to x again, with respect to x, right? And the integral of cos is obviously, like we said, it's sine x, okay? That's the integral of cos x. And then minus now the integral of 2 cos x sine squared x. Well, this is very nice. Here is the rule. Here is the general rule that you must remember. Watch this general rule very closely. What this general rule says is that if you have, check, let me just go and put it here. General rule. The general rule is for two cases. First is if I have the integral of cos to the power of n theta multiplying sine theta, and O is with respect to theta. So in other words, only cos is raised to a power. Sine is just the first sign, okay, just sine theta, right? If I have this and I integrate, I'm going to get the integral of, you know that the integral of sine is negative cos. So here, if I integrate that, I'm going to get negative, okay? It's going to be negative cos to the power of n plus 1, to the power n plus 1. So here it was to the power n, is going to go to the power n plus 1, and this is of theta, and then it's O divided by n plus 1, and you add the constant of integration c. That's for 1, okay? That's for 1. Now for 2, I have sine raised to some power, and then multiplying just cos theta, and it's d theta again. Well, here I increase the power of sine, but it doesn't go to the negative, so it's just sine to the power n plus 1 theta divided by n plus 1, and then I add my constant of integration c. That's a lot. Yeah, it's not a lot. So if I come here, what do I have? I have sine raised to a power and cos not raised to a power. So I can take this 2 out because it's just a constant multiplying, right? So I can say, well, it's minus, I can put the constant out. It's just a number multiplying. If it's a constant that multiplies, you put it out, okay, of the integral sign. So it'll be 2 by, what am I going to get here? I said if sine, if we look here, if sine is raised to a power and cos is not, you increase the power of sine by 1, but then you do not make it negative. So here is going to be sine to the power of 3x divided by 3, okay? That power, that new power is what we divide by. All right, we'll add our constant of integration at the end. It's still fine, okay? We'll add it at the end. It's not a problem. So here, you then see that I have plus, now sine is raised to a power again, and cos is not. So I'm just going to do the same thing. It's going to be sine to the power of 5x now, all divided by 5. And then at the end, I add my constant of integration, c. Wow, really, yeah. So this is how simple it is, and I'm going to get it being equal to, therefore it's equal to This is what it was, and therefore it's equal to sine x minus 2, and then it's divided by 3, so it's going to be minus 2 sine cubed xo over 3, and then plus sine to the 5 xo over 5, and then plus the constant of integration c. And then you would have fully evaluated your integral. Fully evaluated your integral by knowing this. So this is how nice, yeah? That's how nice it gets when I have this integral of cos to the power of 5x with respect to x. This is what my final solution will be. All right, see you in the next video when we do the next example.